This video is going to look at the ideas of compound interest and how to apply that, and the kind of ways you can do that quickly and simply. So a typical problem on compound interest would look something like this. Usually it's a money type problem, and this is typical, the idea of investing some money and seeing a rate of return over a period of time. So the key thing is to find the three main bits of information that I've highlighted here. In text, the £300 is often called a principal, an initial amount that's invested or spent or something like that. Then you've got the time. This is normally in years. They don't normally work with anything other. And the rate, the amount that the, if you like, percentage change each year. Usually an interest rate, an APR, but some sort of percentage. So we're going to look at how these three work, and we're going to start off by looking at some simple interest ideas first. So simple interest is this idea that you get the same amount of interest each year. And so from the problem we've got 4% interest rate on our £300, which would work out at £12 per year. So the first year's interest is £12. For a 5-year investment, that's £12 a year, giving £60 overall. And then if you add this together with what you got, £360 being the total amount in the account. Now that can be a bit unrealistic. Most people would probably keep the money in the account rather than taking it out each year. So what we can do is look at an idea called compound interest, which is what we're going to move on to. Compound interest relies on the idea of keeping the £12 in. So at the end of the first year, yep, you got your £312. But next year, you're going to have your £312 plus 4% of that. So that would work out to be £12.48. You add that on, you've got £324.48. So the amount of interest you've got goes up a little bit more. It's called compound interest because the interest is compounded. It's sort of accumulating on top of itself again, because you've got slightly more in your account each time. And so this amount that's added on changes. So after 2 years, fine. Then 3 years, you'll end up with this amount. And then after 4 years, you're going to have a bit more. And then 5 years finishes off with £365. Now, that's a lot of working out. There's a lot of stuff going on there. And we've had to do a bit of rounding on the way, because the amounts of money would end up going less than a penny. So you'd actually have to round a little bit. Now that can cause some slight mistakes, some slight errors, so there's a way of avoiding that by using a formula. The compound interest formula looks like this. It probably looks worse than it is, but it's straightforward. You start off with your principal, the amount of money that's been spent or invested, and then you are going to multiply that by 1 plus the rate of interest or the rate of decline, depending on the problem. And then this is to the power of time, usually in years. So the problem we've just done would look something like this. You'd have £300 times 1 plus 0.04 to the power of 5. You'll notice the rate I've written in its decimal form. This goes back to the idea of multipliers, which is something I've mentioned in a couple of my videos on the percentages work. So it's something that you should have come across hopefully in some of the other stuff. And then when you do this calculation, you immediately get your answer of 365. You don't have to do anything else. It's all taken care of you. Now, some problems at GCSE, you will actually find that they will miss out certain bits of information and you have to figure it out. So in this case, yep, you're given all that information, you have to find the end result. You might be given the end result and has to find out how much must be invested. You need to work around the problems, but this is the basic rule that you would work to. Now this problem looks at the idea of what happens if it's a decreasing problem. So a car decreases in value, so we're assuming a certain percentage per year, and how much would it be worth in 6 years from time. Okay, this ain't entirely realistic, but it is a kind of problem that we could look at and use the compound formula for compound interest to figure out what's going on. So again, you're looking at the problem. There are your three main bits of information. You've got your principal in the middle, your percent at the top, the amount of time in years at the bottom. So put this into your formula, only this time you want to subtract the rate, because this time it's a decrease. So it's exactly the same, but just make sure you take it off. This creates this calculation, which if you then substitute the values in using a calculator, you'll get out this answer. Now, this is quite common for calculator problems. It's very rare that this would come up in a non-calculator test, so you will be expected to use a scientific calculator to do most of this stuff. And again, the problems can vary slightly, but this is only to go through the basic ideas. Hopefully that's proved useful, and thank you for your time.